We're going to move on and learn more identities. Here is our second set of identities. Besides just the Pythagorean identities and those reciprocal identities, we're going to talk about double angle identities today. There is a double angle identity for sine, and you can see what it means by double angle. Usually we talk about something happening to the sine of x or to the cosine of x, but if we doubled that angle, that would be 2 times the original angle measure. So this is what it means by double angle. You can see that all of those angles are doubled. There's one double angle identity for sine, one double angle identity for tangent, and there turn out to be 3 equivalent identities for cosine. You can use any of these 3. Use any one that helps. You don't just have to use the first one or just have to use any of them. If you are dealing with the double angle identity for cosine, use whichever one of these helps you rewrite your left-hand side or your right-hand side to solve your identity. If you are just using the double angle identity to find a value given an angle measure, then you're just going to substitute in, find out what the value of x is, and substitute it in to the right-hand side here, which is equivalent to your double angle. So let's do some quick examples. This is not very complicated. This is much more about memorizing and knowing these identities than it is anything else. So we're going to use the double angle identity to find the exact value of each of these expressions. So this first expression, if we want to use the double angle identity, then I'm going to have to rewrite 4 pi over 3 as a double angle. So I need to basically factor a 2 out of my angle measure, which is what I've done here. So if I'm going to use the double angle identity for sine, which the sine of 2x is 2 times the sine of x, the single angle measure, times the cosine of x, the single angle measure. So this is going to look like 2 times the sine of pi over 3 times the cosine of pi over 3. Now, we know the exact values for those two trig values. So let's go to our unit circle and let's find them. We're at pi over 3, which is that angle right there. We know the coordinates to that point are 1/2 and root 3 over 2. Cosine is 1/2, sine is root 3 over 2. So the sine of pi over 3 is root 3 over 2. The cosine of pi over 3 is 1/2. So that 2 can cancel with that one, and the exact value is square roots of 3 over 2. We're going to do the same thing here using the double angle for cosine. So if I factor a 2 out of pi over 2, what I need to have left when I multiply that back in is I need a pi over 2. So 2 times pi over 4 does give me pi over 2. So we can go back. We can choose any of these that we want. It doesn't matter. We'll just choose the top one. Cosine squared minus sine squared. So now, and that's of the single angle, right? Single angle measure, which for us is pi over 4. So let's just use that to substitute that value in. We have the cosine of pi over 4 squared minus the sine of pi over 4 squared. So we have square roots of 2 over 2 squared minus square roots of 2 over 2 squared. I would do all the algebra and clean it up, but it's not necessary because at pi over 4 they equal one another. So that's just whatever this simplifies to minus the same thing. So that would be 0. Now let's do the same thing here with tangent. We have the double angle formula or identity. So that's going to be a single angle measure of pi over 3. So it's 2 tan x over 1 minus tan x squared. So it's 2 times the tangent of pi over 3 over 1 minus the tangent of pi over 3 quantity squared. So right back here, here's pi over 3. Tangent is square roots of 3. So 2 times the square root of 3 over 1 minus the square root of 3 squared. So that is 2 square roots of 3 over 1 minus 3. So that is 2 over negative 2. So that's going to be negative square roots of 3. So not very difficult. Just write down, make sure that you have all of these identities written down correctly and that you could do that on homework. There is one more thing that I want us to see that follows from these double angle identities for sine and cosine, and it's called lowering powers. We can use these identities to go from double angles to single angles, but we can also use them to reduce powers. If it's true that the cosine of the double angle 2x is 1 minus 2 sine squared, then I can solve this for sine squared, and I can use it to go from a single angle to a double angle measure. I can also use it to go from a squared term to a single term. So we can do this. Sine squared equals this, cosine squared equals this. I don't have any examples where we can use these, but make sure this and this is in your notes, because we can, oh sorry, I do have examples, they're right here. If I want to simplify the sine of x raised to the power of 4, this is the sine of x raised to the power of 4. I can use these power reducing, power lowering identities to help us out with that. And then everything, once I make this substitution, which is sine squared equals this, everything below that point is just algebra. It's just squaring, it's multiplying this times itself. We could do the same thing here. We can lower the power on sine squared and cosine squared being multiplied together. So that's something, actually, this is something that we will do quite a bit in calculus. It's just something that I want you to see here. I don't have any of this on your homework. It doesn't mean that I don't want you to know it. Those power reducing formulas are there, and we will be using them next year for certain. I just wanted to take the opportunity to show those to you because they follow from the double angle identities that we'll be using in class tomorrow. So come to class next time and we'll work some homework.